Okay, here's our nice little shop light. Just took it out of the box, and we're going to simply take it apart. So the first stage is you got to cut the old cord off. Now, if you're like me and you don't like to throw anything useful away, you're going to cut it off about 1.5 inches away from the end so you can use the plug over again if you ever find the need. And then we're going to pull off this label. And then we're going to strip the ends. One technique that I find works pretty well. Zoom in so you can see it better. And actually refocus a little bit. Okay. So basically you just take the outside covering and very slightly, using the pliers, just make little tiny cut marks all the way around, and then you bend the wire like this. Now if your cut marks are deep enough, which it's not, the insulation will break back at that point. Where are we here? Looking at this thing backwards here. Right, there we go. Okay, and then once you get it started, it's fairly weak insulation. You can just peel it right off. Zoom back. Of course, it's going to fight you when you get the camera going, so that alright. Now, some of these have fabric inside and some of them don't. You're going to cut the ground wire off because we're going to use another grounding path. Alright, so that takes care of that. Oh shit. Okay, next thing, take the screws out. Now, the back cover that we're going to replace with our heatsink assembly is quite a bit thicker than the heatsink assembly is going to be. So these screws are too long, and if you try to reuse them the way they are, you're going to end up breaking the case or breaking the screws off in the holes, both of which are not good things to do. So if you've got yourself a good strong pair of cutting pliers like these things are pretty tough, and the screws are not very hard, so that's the advantage, is they use cheap screws, so they'll be fairly easy to cut. But basically I'm just suggesting that you take the screw, you cut off about 1/4 inch. Do this to all four. Alright, your screws are now short. Now this case can be stuck on there pretty good because of the gasket, so a sharp blow to the side usually will release it. And then this switch assembly is finger tight. Put it back on so you don't lose the parts, because it's a nice part to have for future reference. And stealing my tool here. Okay, so now let's zoom in a little closer so you can see what's going on in here. Refocus and reposition. Let's see. There we go. Okay, maybe you can zoom out just a smidge. Right there. And how's the focus? Pretty good. Alright. Okay, so the switch is attached with these little wire nuts. I've seen some of them so loose that you just touch them and they fall off, and other ones are so tight that I had to cut the wires and had to throw them away. So you can see the consistency of Chinese manufacturing here at its finest. So you're going to take them all off. You're basically going to disconnect every wire in the thing. Okay, now save these because you're going to use some of them again. Now you can remove the switch, which is kind of a neat 3-position push switch. Put it in your switch box for future reference. Okay, so now what do we have here? We got a ground wire, which we're going to reuse. But as you may remember, we cut the green wire off the other side. So what we're trying to do is get this black wire, which needs to go to the transistor, so that it's got as much length as we can get. And you can see here how the insulation from here back to here is covering the wire, so it can't be separated. So we're going to take our cutting pliers and we're going to go in there and very carefully, so we don't cut a wire, open that back up again. Okay, and the black wire that comes from the cord is the one we're concerned with. This is going to be the negative of the battery. The white wire will be the positive of the battery, and you'll see what we do with that in a minute. Okay, so now that's going to be one of our attachment wires to the cover. So I'm pulling it out the side here so you can see it. Now what else do we have? We got the fabric insulated wires coming right from the light bulbs themselves. And you'll notice that there's 2 black and 2 white. I'll put these blue wires, which are the thermal sensor, out of the way. Okay, so here we have a black and a black. You can't see very good, but there it is. Now what we're going to need is one of these wires, whether it's this white one or the black ones, needs to go to the transistor. So let's pick the longest wire that's here. Now if it happens to be a white wire versus a black one, the other white wire will become the positive input from the harness, which will be this white wire. So again, let's get this so you can see what I'm doing here. So basically I'm taking the 2 white wires, the one from this cord, okay, and the one that comes from the other side of the light. And I'm going to twist them together and put one of those nice orange wire nuts securely onto it. This will be the positive from our battery going into the bulb assembly. Now the 2 bulbs are going to be put in series. So normally the 2 white wires were on one side of your AC and your 2 black wires are on the other side of your 120 volt AC. But in this case we're going to separate them. Okay, so the 2 wires that we're going to attach go here. Now the ground wire in the harness going to the car is not going to be used, so let's cut it off to get it out of our way. And the blue wires, which are the thermal sensor, there's a short one and a long one. Again, we want the longest one to be giving us our best shot at connecting to the power transistor. Let me move the ground wire out of the way for the moment. And now what we're going to do is we're going to clean the ends of these wires, make them nice and twisted and compact with no stray strands. And before we do that, we're going to take the 2 black wires. Now, had one of the black wires been the longest one, we would have tied the 2 white ones together. In this case, one of the white ones was the longest, so we'll tie the 2 black ones together. It really doesn't matter because all we're doing is putting the bulbs in series, and if you put them in series on the black side or the white side, it don't really matter too much electrically. And from the standpoint of wiring this up, the longer the wires we have, the better off we are. Alright, so now we twist those together. And so here's the series connection of the bulbs, which is the black wires in this case. Here's the positive wire from the battery going to the bulbs. And the result is the black ground wire from the battery, the positive wire from the string of bulbs, which was connected to the positive side of the harness, and then we're going to clean these 2 things up. So this is where we get our soldering iron. I'm going to zoom in a little closer. Let's see if I can jigger this around a little bit so you can see better. But basically what we want to do is we want to tin the wires. So you put your soldering iron there, apply a little solder in between until it starts flowing into the strands of the wire. Now you notice I'm using the side of the soldering iron rather than the tip. This gives you a little bit higher ability to put heat into the work, and these wires need a lot of heat to get hot enough for the solder to flow nicely into their structure. And these wires from the bulb itself actually need more heat because they're coarse wires, and you need to get in there and get the wire to flow, heat solder to flow nicely. Come on, baby, come on. Be patient, this is important. You want to get this to be a nice tinned wire ready to solder. I want all the strands to be working together, which is why you're soldering them together. And you'll know you're hot enough when your solder starts flowing when you touch the wire rather than the iron. Okay, so there's those connections right there. We're going to cut the ground wire back so we can still get to it but be out of our way. And while we're touching this ground wire, we're going to also solder it in preparation for the next step. Only has to be soldered on the very end. Okay, the next part of the procedure is to drill the hole for the wire to come in that does the controlling of the light. So I'm taking my trusty drill here with the I carefully measured the diameter of the wire, added about 5/1000ths, and then made that selection for the drill. Rotate it around, make sure the hole's clean. Dump out the chips. Okay, now we can bring that wire in to our new opening. Now, one of the things that makes wires that go into enclosures break is the wire bending back and forth while you're moving the device around. Now, a lot of times they'll do something like this, where they'll basically have a clamp that has a little bit of play. What this does is allow this motion to be smooth and take place over about a ½ an inch of area rather than having it happen all at once. Now, unfortunately, our connection is not quite the same. This will happen all at once. And you can see how a motion on the outside will move the wire on the inside, which means it could eventually break a connection inside. So we're going to use a interesting technique that I've developed to hold this wire and strain relieve it as it comes out of the hole, and also immobilize it inside. So we start by stripping back a generous amount of this wire. Let me zoom back out a little bit. A generous amount of this wire. I'm talking about 2 inches here. And again, I used the very tips of the pliers to make a very slight incision in the outer jacket. And then I bend the wire. You can see how it opens up on that spot. Let me try to zoom in. The trouble is this camera's in a weird spot, so I don't know where I'm looking. But you can see how when I bend the wire, it becomes, you can see the insulation or the shield underneath. So then you simply grab it further up and pull it, and there's very little danger of damaging the wire if you do it that way. Okay. So now we've got this long length of wire. We don't need the shield. So we cut off the excess so it don't get us in trouble. And then we have 3 wires. The white wire will be the new ground. The white wire will be the ground. The red wire will be the positive control signal from the computer, and the black wire will be the ground that'll go to the MOSFET. Now, since we're going to put a resistor in this red lead, we cut it about 1 inch from the end, and then we strip the ends of the white, red, and black. Now, in order to strain relieve this so it can't be pulled back out again, we're going to use some hot melt glue and also a tie wrap. So we're going to take a tie wrap and use it in a non-conventional way. I'm going to basically hold it like this. Let's see if I can get it so you can see what I'm doing here. It's a little tricky with this camera. So basically you put the tie wrap like that, and then you're going to wrap it around one whole time and then stick it through the hole in the tie wrap. Okay, so when you're done, you got this loop that looks like this. And then right near the end, you're going to take it and tighten it up very securely by not cutting with the pliers, but just making it support it, and then pull, and then cut. So now you've got basically a bumper there that won't move, that'll stop the wires from pulling out. Okay, so the red wire, the black wire, and the white wire. So now we're going to slide this in. Let's refocus here. Okay, so I'm going to slide this in like this, and at this point, get the wires where we want them. We're going to tip this device on its side so gravity is working with us, and we're going to squirt some hot melt in there. This dual heat gun has got some nice features, which is that it can be adjusted to a high or a low range. I've just put it on the high range so it will be kind of fluidy and flow into the small nooks and crannies. And in order to make it flow better, I'm going to tip this thing on its side and let gravity kind of help us get the hot melt to flow where you want it, which is right in that corner to hold everything in place. And then we add a little bit more hot melt if it needs it. And now you can go have a cup of coffee and wait for it to... Okay, now we've got the... you can see clearly how the hot melt has hardened right here into a secure thing. And now I can wiggle this wire and nothing on the inside moves at all. Okay, so that's what we want. So now that we've got that wire anchored in place, let's connect the ground connection. So this is the ground cable, the ribbon from the inside. And here's the wire that goes to the ground on the harness. Let's start by tinning the wires, leaving a little lump in place, using some long nose pliers to control the wire. Don't burn yourself. Once the wires are soldered, push this down out of our way. Next wire we're going to prepare is the blue, one of the blue wires, the shorter of the two. It's going to become our power input. So it's already been tinned. It's already been tinned, so we'll just strip off a little bit of the extra. We don't want any excess wire hanging off of any of these. So I'm trimming them to about 1/8 of an inch of bare tinned wires. Now that I've cut them, I'm going to reflow it. Make sure we have some fresh solder with plenty of flux. And the way you do that is you just don't let it sit there too long. As soon as you get it coated, you pull your soldering iron away, and then this liquid solder hardens and you leave a little bit of flux on it. Okay, now that we've got all these guys nice and trimmed, I'll do the finishing touch. Okay, so we take a piece of heat shrink and we slide it down over the shorter of the two blue wires which go to the thermal switch. The idea here is to get it down deep so that we don't have it anywhere near the end that we're going to solder to. So now we've got a little resistor, 220 ohm resistor. Trim off one side and then tin it. The tinning is an important step because what it does is it does the process of adhering fresh solder so that the two solder joints will easily connect to each other and flow against each other. And the key here is not to overheat it and then expect there to be enough flux to make it happen. So right here, the blue wire is held there by its position. Heat up both. There we are. Now we're going to trim the other side off. Again, we're going to tin the wire. And make sure that the little red wire that's going to go to it's tinned as well. This comes from the control harness. And then we want to solder those two pieces together. So we're going to start by taking this resistor and the wire, making sure they're tinned on the end with a little extra solder so that we don't have to add solder when we're trying to get them to stick to each other. Okay, there it is. Okay, so what you can see is we got this resistor soldered on between the blue temperature sensor probe wire and the control input wire, which is the positive signal from the computer. It's going to tell the thing to turn on. And so if it overheats, even though the computer's telling it to turn on, it will turn off and keep the box safe. Okay, so now that we've got that in place, we want to shrink it down. Okay, now just like we did with the white ground wire, we're going to make sure this wire stays down out of our way and we don't stress the resistor joint. So I'm going to push it down in there like that. Get our black wire, which needs to go to the heatsink up above. Tuck everything else down in there. And in order to keep it where we want it, we'll use the hot melt gun to put a little dab of hot melt here and there to tack it down and keep it under control. And while we're waiting for that to solidify, we'll get our 4 wires that go to the power transistor ready. Okay. So while we're doing that, here's the power transistor. What we're going to do there is we're going to trim off the excess lead length. And we're going to give yourself a little more clearance between the pins by basically bending these things out slightly. And then we're going to want to tin them with the solder, just like we did the other one. Okay, and now we're going to place this down like this. Let's see if we can get a little better look at what we're doing here. Okay, so we're going to start with the white wire, which is the return from the positive lead that went into the other white wire. Since we've tied the two black wires together, we've basically put the bulbs in series, and now what we're going to do is we're going to make a nice secure connection to the power transistor. The idea here is to keep it well away from the base, so there's no danger of it shorting out. Make sure there's a secure solder connection. And now, because of the difficulty in lead lengths here, we don't really have room for this black wire to make it up to where it has to go. So I'm going to change this thing around and get a new position with the camera. Okay, so we've got the light tipped on its side. Get a picture of how it looks right here. And we lay this little box, this little heat sink with the transistors there. And now we've got to attach the other three wires. So let's zoom in here. Okay, so you'll notice that there's actually labels on this little board here. Plus high voltage will be the return wire from the lamps. This is the ground that goes right to the output cable. This is the control line that comes from the computer after the resistor passes, the signal passes through the thermal cutout and comes back to the blue wire. And then this is the negative control wire from the computer. So let's start with this next wire, which is the black high voltage wire, and it goes right to the negative lead on your battery pack once the connector's plugged in. Make sure you got some fresh solder there. And then we're going to do a very careful little reflow here. So basically you let the wire sit where it wants and you move the heatsink to the part until you're just slightly deflecting the wire, and then you heat them both up until the solder flows. Now that wire is securely attached. Next wire is the black negative lead from the computer, the charger. Again, we let the wire sit where it wants and we move the heatsink to it and then reflow the solder. That's nice. And then the final wire will be this blue wire coming from the thermal switch. We're going to connect that right to the last lead. And here we are. Okay, now these wires are probably fine just the way they are, but I like to add a little insurance. Since the high voltage from the battery is right here, let's just make sure nothing can get in the way, nothing can hit it, and nothing can rip it off. Even if these wires move now, by adding this heatsink, hot melt, it acts as a protective layer and also a mechanically clamping thing. Now because this stuff is so fluid, I'm going to turn it upside down, which you won't be able to see, and therefore let the stuff flow more directly. And as it starts to harden, this need to let gravity move the melted material in the direction we want becomes less important. Let's see if I can get us a better view of this while it's solidifying here. So basically I'm just hanging it upside down until the stuff gets hard. This is where having the heat gun set to the low range increases the viscosity because it doesn't melt the material quite as much. So now you can build up another layer on here with a much thicker viscosity material, less likely to droop and flow down. And now we've basically captured the wires and strain relieved them, as well as insulating the high voltage connections and making them so they can't move relative to each other. So that's the final attachment procedure for that. See if I can get us so we can see what it looks like there. Okay, so we're going to let that harden and then we'll... Okay, so now we've got that material hardened up and the box is pretty much ready. So you take the hot wire from the battery, the white wire, connect it to the white wire or the black, depending on how the wire lengths work. The other two wires to the lamp get shorted together. Your control cable is hot melted in so that it can't move. Your ground is connected, and now we're going to simply take this heatsink, push the wires down inside, and rotate it into the final position. And here we'll put the screws in, and this end of the unit is all set. The shorter screws that we made should have no trouble going in. And it's a good idea to get them kind of all started before you finish off tightening them up. That way everything gets a chance to find its ideal position. There we go. Alright, and that's that. Now the last thing to do is to put the connector on this end. So, okay, so we start by doing the same trick where we just basically take the very tip of the thing, being careful not to cut the inner wires, and then we bend it back and forth in order to expose the sheath. Then we peel off the shield. Now you may or may not have shielded wire, but that's what I'm using just because I had it. Now we get our three wires of interest, red, black, and white. White being ground, red being the control signal, and black being the ground. Again, we leave about 1/4 of an inch of bare wire on the end of each, and because this wire is small compared to the wire size that the connectors are designed for, which is 18 to 16. This is more like a 22 wire. I'm going to bend the ends of the wire over in order to double up in the area where the crimp is actually going to go. I'll take a look at that right there. So now, using the special crimping tool, That cost 150 bucks. We're going to crimp the connections on the end of the wires. Goes number 1. Goes number 2. And there goes number 3. Because these want to be nice and narrow, because the crimping tool I'm using isn't exactly the right tool, I'm going to go like this. Now this is an important aspect of this particular connector. Actually, let me get a little closer here. Okay, so if you'll notice, these connectors have a little tab on, oops, there we go. They have a little tab that sticks out the back, and they have a flange, and when you go to put those into this connector, you have to be careful because there's actually a little track that these things have to go into. If you don't put them in right, it won't work correctly, and the pin will be crooked. Now it's important that you have your heat gun setting on the low setting when you're doing this, so that the viscosity of the hot melt is quite high. It means it's like cold honey. Okay, so the connector has a step in it. If you see that little step right there, you want to put that so the step is at the top when the little slots are looking over here. And then you're going to slide this black wire in, being very careful that you get that flanged area to slide in as it should. If you get it right, it clicks right in. If you get it wrong, it's going to be crooked and it won't go in at all. It helps to keep this nice and straight when you're putting it in. Okay, the next one is the third one. And then the next one is the fourth one. So you leave number 2 position open. Oops, that one didn't quite go in right. It helps to have a little screwdriver or something to pop it in the rest of the way. Okay, if you got it in right, you can pull on it and it won't come in or out. If you look in the end, you'll see nice clean holes without anything blocking them. And now we're ready to do the final strain relief. So what I do is I push this down like this, and I'm going to back off a little bit so I don't have to be so fussy with my focus here. And now the heat gun has been cooled off a little bit, and we got some nice high viscosity hot melt. And then we're going to flip it over, put some more over there. And it's real thick. And I'm going to rotate. This is going to be the strain relief. Now that you've got it there, it's still a fluid, so you want to let gravity mold it to the shape you're looking for. Another little trick that works is to wet your fingers with saliva, and then you can tap it and it won't stick to you. Whoops, lost the spit. If it's wet, it won't stick, and it helps it to solidify faster. And the idea is to get it to act as a nice strain relief for the wire. And something like that. Now all this while it's still continuing to move if you let it. So the trick is to tap it with your damp finger, and you can shape it into a nice rugged strain relief, so you can pull and push on this without any issues. And there you are. You got this end ready for attaching to the harness, which is what we're going to look at next. Okay, so here's the so-called extension harness, special extension harness. So basically you take the two ends from the wires, you strip the insulation on the blue and red wires from the harness back, twist the wires around it, solder it, and then cover it with 2 layers of heat shrink in order to make sure you have a nice, secure, and high voltage and well insulated connection. And then you crimp on the pins, put them into the connector, and you have yourself a discharger.